So let's get started with space. What in the world is space? Well, let's quickly review what we did last week, which is the fact that we looked at time, and we said time is not a dimension as is portrayed by the establishment. No, it's a number line. And what is interesting, is that they say it's a dimension or a coordinate, and it turns out that time doesn't have direction, and it has orthogonality with respect to nothing. It doesn't run perpendicular to anything. It doesn't have direction, none of that. And they say it's one of these guys here. It's what our dear friend Rene Descartes invented, which is the Cartesian coordinate system. And no, time is not, doesn't belong there. Maybe in math, but not in physics. And the reason I can tell you that without any problem is that you can see those lines are running perpendicular. And, if it's perpendicular, you can talk about dimensions or coordinates because that's one of the features they have. They also would carry an arrow like you see there because they have direction. But number lines, those numbers that you see there, they have neither perpendicularity to each other, and they don't run, and they don't have direction. So something is wrong there. And so we like to distinguish that from what the establishment does. The people out there, they use these number lines and they call them dimensions, and you can see that there is a big difference. The difference is that physics is qualitative, whereas math is quantitative. And that's what the problem is. These people confuse the tops with the bottoms there. They say that what they have down there, those numbers with an arrow and the dotted lines, they say those are dimensions or coordinates or whatever they call them. No, absolutely not. Those are not part of physics. They are known as number lines, and that's all that mathematics has. It doesn't have qualitative concepts in mathematics. Mathematics is all numbers. So these people, are bringing their math into physics and calling it either physics, straightforward, or mathematical physics, which is a synonym. And no. Neither one. Okay. And so, yeah, they have this thing they call time, and they say it's a dimension, but it's really a number line. Number lines, as you can see there, don't have any direction or perpendicularity, because they're numbers, they're values, they're comparisons. That's what they are. And so, what do you mean when you say 5 seconds? Well, you're making a comparison between the hand on your watch and the motion of the earth around the sun. So you're comparing two motions. That's what it is. And that doesn't have any perpendicularity or direction. So yeah, it's not a dimension or a coordinate, or a vector for that matter. No, it's a number line. Number lines don't have any direction whatsoever. You can put them in you can put numbers in any order you want. You don't have to put them sequentially. You can put them one here and the other one there. They don't have location. Okay, so you can't talk about the location of a number. And that's what these people do. And they do it also for the word field, by the way. Okay, so they have this time passes. They say constantly, time flows. It flows like by me, yeah, and they give it a direction. They also put it perpendicular to space. And no, it's irrational to do both. You can't put a stick to represent time, okay, and you cannot put an arrow or put it perpendicular to what? Space? What is space? And since they can't put all three dimensions there, and they always complain about that, they say, well, what we do, we represent all three space dimensions, length, width, and height, we represent it with a single line. Now, that's not space. What that is called a number line. And they have a number line at the bottom and the other one, standing up. That's okay as long as they keep it within math. No problem. But this has nothing to do with physics. Physics is qualitatively only. Okay, it's explanations, rational explanations of gravity, light, magnetism, electricity, workings of the atom, that kind of thing, right? Okay, so here we have these folks, and they created the space money diagrams. You know, time is money, so they created the space money diagrams, and they use it for both quantum and for relativity. And I guess if you go upwards on the time, also known as money, coordinate or dimension or whatever that is, then you're rich. And if you go down to zero, then you're very poor. And hopefully you don't get into imaginary money. Okay, so yeah, it's all nonsense that what the mathematicians have come up with to describe, right? Which is all that they do. They cannot explain with these mathematical concepts, with these quantitative concepts. They cannot explain a mechanism. They cannot explain why, my pencil falls to the floor. And they say, yes, we can. Time is warped. We warp time. And that's what they do. And, what are you going to do? These are the explanations you get today. Okay, so if you go to college, the higher up you go, the more irrational it gets, because they start talking to you about, warping of time, of space, And the question is, are these things qualitative, or are we talking about something quantitative? When they talk about space, they're really talking about measurement, about, again, number lines. So even though, you have length, width, and height, and that's what we normally associate with, with things, that's not what they're talking about. They don't talk about things at all. They talk about measurements, about numbers that they're going to put somewhere. And so when they put the word space, it's extremely misleading, because they're not talking about space, they're not talking about dimensions, they're not talking about coordinates. What they're talking about is numbers, something they measure, and they're going to put a value there. Okay? And when they put the time, they say, well, this was the location, and this is the time it was at that location. That's what they're saying. Okay, so, the title of the press today is, Space, a Frontier. You saw the Enterprise, so many years going out into space and say, space, the final frontier. Where did the people in Hollywood get that? From the mathematicians, obviously, right? So is this true? Is space the final frontier? And so you look at the word frontier, it says that part of a country, right? Or a region, I guess, that borders another country. A boundary, a border, right? So they're talking about the boundary, like it's separating you from something else. And the question is whether space is separated from something else. That's one of the issues we got to discuss today. Okay? Can we separate space from something else? Is there something outside of space giving it shape or encapsulating or serving as a boundary? And then the other notion that they have is the colonization kind of notion, right? The land or territory that forms the furthest extent of a country, settled or inhabited regions. Okay, so you colonize the land, and up to the point where you got there, that's the frontier. What continues are the Indians. Okay, so the barbarians, in the case of the Romans, they had their limit, came up all the way to here in Germany to the Main River at times, and so yeah, that's what's called a frontier. So which is it? I mean, when we talk about space, are we saying, when we say it's a frontier, are we saying that's the part of the universe that we colonized? Maybe that would be great in in science fiction. How about as a line dividing us from whatever encapsulates space? Maybe the fifth dimension or something like that. I don't know. This is what you got to think about. Is there a limit to space where you get to a point where you hit your nose against the wall? Okay, that's the issue. Okay, and so when you have a question about space, hey, why not go to the experts? And so I went to the Stack Exchange. A bunch of so-called physicists, mathematical physicists out there. This is what they have to say about space, okay? And so the question is space a thing or is it a concept? is it filled or is it not filled? Is it empty or full? These kinds of questions. And these are their answers. Two guys in there, and they have completely different answers, both mathematicians. Listen to them. Okay, so one fellow says, the vacuum is empty in every precise sense of the word. What we call particles in quantum field theory are states created by so-called annihilation and creation operators, which represent subtracting and adding a particle of a certain type to a state. The free vacuum is by definition precisely the state from which you cannot subtract anything. Hence, it is empty. Okay, so we cannot subtract anything from space, okay, or the vacuum, right? And so that means that is completely empty. We call it vacuum, meaning it's empty of things, but that doesn't tell me what this vacuum thingy is. What is it? Is it a container of some kind? And here you have space is not, the other fellow, right? So space is not something seething, some seething mass of particles like electrons and positrons, or protons or antiprotons, or photons or neutrinos being created and destroyed. Space is not nothing. Okay, so one guy says it's kind of empty, like saying it's nothing. This guy's saying it's not nothing. So what is it? Well, it's got vacuum fluctuations are real. The guy just finished telling us that vacuum is empty, there's nothing there. And this guy says the vacuum is fluctuating. It's moving, it's vibrating or oscillating somehow, right? Moving up and down. So we have a discrepancy here, and these two are people who are trained at the same monastery, essentially, right? So it says they are the electromagnetic equivalent of the little ripples on the surface of the sea. Yeah, the problem with the ripples on the sea is that what's rippling is water. It's known as water, So you can talk about the rippling of water. You cannot talk about the rippling of nothing. So one guy says vacuum is empty and there's nothing there, and it's absolutely nothing. What is it that is rippling? What is it that is oscillating? What is it that is vibrating? That's the question. And so, yeah, we have a little bit of a problem there, because these people are supposedly educated at these monasteries, and this is what they come up with. They still don't know. They have no idea what space is. One calls it the vacuum, says it's empty. The other guy says, no, it's full, or even if it's not full, it vibrates, the vacuum vibrates. What's vibrating? Like the ocean, the sea. No, ocean has water. That you can say it vibrates. We have waves. Yeah, we can all understand that. We cannot understand the waving of nothing. And that's where the problem is. And so the question is, again, is space a container? Here's some examples of containers. We've seen them around. Right at the bottom, you see two waste baskets, and, they are containers. One is full, so we have a container that is full. Let's empty it. That on the right, lower right there, right? Now it's empty, right? And so the question is, that empty one, it's an empty container, but it's a container on its own. In other words, I see something there. I see some black stuff giving it some form or background, contrast. So what I'm staring at is a thing. Can we do that with vacuum or with space or whatever they call it? We empty it. What's left? What remains behind? Do we have a waste space? Is it a container? And if it's a container, what encapsulates it to give it shape as a container? Because that's what you call a container. That's an object, that's a thing. And that's what space would be if it had something encapsulating it, giving it shape, giving it contrast. So we need that. We need to know what's on the outside of space. Okay. Turns out that you go to other experts. Here's another expert. This one's from Cora. And I think it's a she. She says, the question posed to her is, if space is expanding, what is space expanding into? Right. In other words, what is on the outside of space? What encapsulates space? That's the question. And it says, your question is based on a common misconception. Oh, so we have a common misconception. Okay, let's see what the misconception is. There wasn't ever any space for the universe to expand into. Yeah, I mean, if space is what's expanding, I guess it would not expand into another space, right? I mean, what's the difference between these two spaces? Are we talking about two empires that, reached a border and there's one empire on one side, the other empire's on the other side? Is that what we're talking about? I mean, we got a problem because there's no space into which our space can expand into. No kidding. It does not expand into a pre-existing space at all. Yeah, there is nothing outside the universe. In other words, outside of space. Yeah, that's like saying there's nothing outside of nothing. Yeah, I agree. You cannot have nothing outside of nothing because nothing is nothing. So if nothing is what encapsulates nothing or gives contrast to nothing, there would be no contrast. We would have absolutely nothing so far. So it says the expansion of the universe is the creation of more space within the existing universe. So what they talk about is what's within. They treat it as a physical object. They're saying there's more space between the visible objects like galaxies, stars, and so on, right? But they treat it as a physical object, but they say there's nothing on the outside that would tell us that it is a physical object by definition. Because that's what an object is, that which has shape. And if you don't have anything on the outside providing the contour or the backdrop, the contrast, right? Then what are you talking about? I mean, there is no object then. And she says, this means that locations that were a certain distance apart are later slightly further apart because new space is being introduced everywhere at all at once. Well, the problem there is that how is space being created? I mean, what's the mechanism? Is there a little machine that creates space? Is that what she's saying? Are we saying that, space is a commodity, a scarce resource, but we can crank the machine up and somehow, right, on the assembly line and create more space? I mean, what is this, God's garage or that we're talking about here? I mean, is this magic? It says this is the same for the Big Bang where space itself was created very rapidly. Yeah, don't tell me it was created. Tell me how it was created. Give me the mechanism. Give me the explanation, physical interpretation, right? The cause. And of course, they can't do that because it's a contradiction what this person's saying. It didn't explode into a pre-existing background. So yeah, this is the notion they have out there. They say that we have space. Space is expanding. Somehow it's growing. Something is fueling it from the inside. More space is being created. But there's nothing on the outside. So it's expanding against what? How can you visualize it? What are you going to put on the board in your presentation, right? You got a balloon, it's expanding. Okay, so it's expanding. What's on the outside? What are you going to put on the outside? You're going to nothing. Nothing is what's expanding. So you can't say it's expanding against nothing. Nothing against nothing is nothing. Okay, and here you have it. This is the famous balloon analogy, and this is what they have for the Big Bang. There's been an explosion or creation of matter in space, and space is inside the little balloon there. Okay, inside that ball, that space, that gray stuff, that's the space. And so the question is, what's the black stuff that's on the outside? That's what I want to know. If space is on the inside and it's pushing against what? More space? You wouldn't see anything here. You would just see stars and galaxies and whatever, right? Matter. And so here we stop it, and there you see, what is this black stuff? Okay, that's what we want to know. And they're saying, all these people are saying the same thing. The official version is that there is no background. There's nothing against which space expands, and space is the black stuff, or it ain't. So what is the black stuff if it's not space? You can't say it's space because space is what's expanding, and so we got we're chasing our tails around. That's what we're doing here. Okay, so that's where the problem is. And if you don't know what space is, I don't know what kind of physics you can teach or you can even learn, right? If you haven't identified in 10,000 years what space is, or defined it, or justified it, or rationalized it. If you haven't done that, what kind of physics are you going to do? Because space is half the universe. It's half matter, half space, right? It's either things that exist out there and that which doesn't, which is space. Space doesn't exist because it's not a physical object, and exist requires a physical object that has location. You don't like the definitions? No problem. Challenge them, come up with your own definition. But, don't tell me that you don't like the definition. That's a poor defense, okay? Okay, so here's my version of what space is. Very to the point, down to the point. Okay, there it is. Something is an object, right? Or a thing, entity, all those words are synonyms. Body, structure, physical, all those mean the same thing in physics, right? That which has shape. That's what a physical thing is. That which has shape. All objects have shape. What is nothing? In other words, space, vacuum, nothingness, void, whatever you want to call it, right? Zip. That which doesn't have shape. So we have that which has shape is the antonym of that which doesn't have shape. Now we can use those two words consistently. The universe is, the word universe, right, is made of those two things. In other words, it's got objects, the things, the atoms, the stars, the galaxies, light, gravity, whatever mediators serve for those purposes. That's on the one hand, we'll call all of that matter, right? A lot of mathematicians don't like that. They say, no, it's energy, that's not matter. No, it's all matter because we're talking about objects, and all objects are matter. Matter is simply objects that exist. That's what it is. And so that's the definition of the word matter. Again, you don't like the definitions? Hey, come up with a better mousetrap. And the other side is space. The emptiness, the nothingness that's out there. What is that? And it's not a what. Okay? It's that which doesn't have shape. All whats have shape. There's not a single what, a single object, a single thing in the universe that doesn't have shape. Because that's the definition of a thing. But if you know of a thing that doesn't have shape, well, I'd like to hear about it, okay? And we're not talking about the thing of ordinary speech. We're talking about the thing for the purposes of physics, about an object, okay? That's what we're talking about. It's either an object or it's a concept, okay? You can't get away from that. And you can see how beautiful that dark space is. Absolutely beautiful, stunning. And I had to put a border to it simply because I have to show something. I'm saying that nothingness, that void, that, blackness, that's space. And it's not a what, it's not a thing. It's the absence of things, meaning it doesn't have shape. Okay? It's not a container. And I'll tell you why it's also not a container in a way, because you cannot escape it on the one hand. In that sense, you could say, well, maybe it is a container. But on the other, you do not displace it. When you occupy space, an astronaut, a spaceship goes out into space, it's not like a fish that displaces water in the ocean. It's either the fish or the water, right? That's not the case here. The good thing about space is you can occupy space without pushing some space over. It's not a physical object. And certainly we do not have this nonsense where that space is made of particles called virtual particles that pop in from the void, from space, come into existence and go back out of existence to form space. What is that? That's absolute poppycock. And again, all that's got to do with equations and absolutely nothing to do with physics, okay? And so, the other issue that you got to consider is whether, if space is a physical object, they talk about it being infinite. Oh, infinite space. And a lot of people have asked that question over the years, of the centuries, really. Does space have a border to space, which is what the presentation is about? Is there a limit to space? Can you go there forever and finally at some point encounter a wall? Or is it infinite, as they say? Well, the word infinite is poorly used. It's misused in that context. There is no such thing as infinite. Infinite is an irrational term. Why is it irrational? Because it's an adjective. Adjectives in physics can only be used to qualify things, objects, entities, right? Bodies. You can qualify them with, say it's black, it's white, it's big, it's small, that kind of thing, right? But you cannot say it's infinite because the definition of thing is that which is finite. So finite and thing are synonyms, and what you're saying is it's an infinite finite. That's essentially what you're saying. And so that's what is it? An oxymoron, right? It's self-contradiction. So you can't use the word infinite anywhere in science. It's an irrational term. What people are talking about when they talk about infinite or infinity, they're really talking about incessant or incessantly, moving incessantly. You're qualifying motion. Whether you use incessant or incessantly, incessant is not an adjective for the purposes of physics. You're talking about motion. You're qualifying motion. You're modifying motion. And so, this is what they're really talking about here. I illustrated it a little bit. When you walk around the earth, you can say the earth is finite. But not like good old Stephen Hawking said, it's unbounded also. Well, unbounded in the sense you don't encounter a fence when you go around. Yeah, there's no fence. But he's not referring to that. They're using the word unbounded wrong here. They put the word unbounded when they are referring to incessant motion. They're saying you can walk around it forever because you won't encounter a fence. That's got to do with incessant walking, not with it being unbounded the way he's intending it. And so, again, when you look at space, you got to be very careful with your language. You can't use the word infinite for space. Okay? And besides the fact that, the word infinite has come from mathematics. What are they saying? What is the context of the word infinite? They're saying you can count infinitely forever, right? And you will not find the last number. So they put the infinity, the lying down 8. Figure 8 there, and they say, oh, it's infinite. But what are they referring to? They're saying that you can count incessantly and not find a final number. Yeah, you can add a number 1 to infinity. Just add a number 1 and now you got infinity plus 1. And you can go on forever, meaning you can count forever. You can count incessantly, not that it's unbounded or finite, right? So again, you got to be very careful. Words like bounded or unbounded, finite, those adjectives can only be used to qualify things. You cannot use them to qualify concepts such as space, which is nothingness, which is not a thing, right? You cannot say space is unbounded. You can only say that if space is an object, and if it's an object, hopefully it is bounded. It can't be unbounded. Okay, so all these things you got to keep in mind when you come up with your notion of space.